Unit 7.5 is a couple of theorems that we're going to use to prove that triangles are similar. We have already learned that we can prove that triangles are similar by knowing that all of the angles of one equal all of the angles of another. But then we said we really don't have to know all three, because once you know two, the other one is given. We also talked about the fact that incongruency, when it says side, it means side equals side. But that's not true for similarity. In similarity, the sides are not equal. The sides are proportional. So when you see an S for side in similarity, you're thinking about proportion. So let's look at this situation right here. It's still side, very next angle, very next side. It is two sides in the included angle. So what we need is a pair of equal angles, because in similarity, corresponding angles are equal. And we need the sides that that angle is between. But instead of knowing that those sides are equal, we need to know that they're in proportion. So we look at the sides that form those two angles, and we're going to put small over small and large over large. See, you're not really going to know which one goes with which one by looking, because you can't just say left goes to left and right goes to right. It may be flipped and spun around, but it will be obvious that small goes to small and medium goes to medium and large goes to large. And if it only gives you two pairs, then you're going to use small and large. So if it comes out that small over small is equal to large over large, that means that the sides are in proportion, therefore they are similar. And in this scenario, we would say that they're similar by side angle side similarity. So side angle side is when you have a side, a very next angle, and a very next side, where the angle of one is equal to an angle of another, and the sides of the two triangles that you're dealing with are in proportion, okay? So let's look at this. Are the two triangles similar? If they are, name the similarity. So what we have is we have an angle of one is equal to an angle of another. So there's our angle equal angle. And then we have the sides that form that angle. One is 6, one is 9. We have the sides that form this angle. So an angle of one triangle equal an angle of another. And we're looking at the sides that form that angle. We're going to be seeing side, very next angle, very next side, side, very next angle, very next side. So we've got a pair of equal angles. Angle A is equal to angle E. And we have the sides that form that angle, 6 and 9, and 3 and 4. So we're going to put the small of this over the small of that, the large of this over the large of that. 6 over 3 reduces to 2 over 1. Nine over 4 doesn't reduce. They do not come out equal, therefore they are not similar. So if an angle of one triangle is equal to an angle of another, and the sides that form those angles are in proportion, they're similar. If the sides that form those angles are not proportional, then they are not similar. Okay? Now, in this second scenario, we know that angle 1 is equal to angle 2 because they're vertical angles. So angle 1 is equal to angle 2. Reason vertical angles are equal. The sides that form angle 1 are 6 and 8. The sides that form angle 2 are 3 and 4. We want to see if those sides are in proportion. So we take the small of this one, 6, with the small of that one, 3. large of this one 8 with large of that one 4. 6 over 3 reduces to 2 over 1. 8 over 4 reduces to 2 over 1. We have an angle of one triangle equal an angle of another, and the sides that form those angles are in proportion. Therefore, we can say that those triangles are similar by side angle side similarity. Now we need to get the parts that go together. Now notice this script down here. This is important. Opposite what? Look at G. G was opposite the larger side 8. That larger side 8 went with that larger side 4. So we're going to come over here and look opposite the larger side 4, and we get angle J. G and J were opposite those larger sides we matched up. Therefore, G must go to J. Okay? H. H was opposite the smaller 6. The smaller 3 is here. Opposite that is K. So H and K go together because they're opposite these sides that we matched up as small and small. So H goes to K. And in the middle, we had those vertical angles, which are both I, so I goes to I. Everybody see how we named the similarity? Okay. In the last way we will prove that two triangles are similar are side, side, side similarity. So what do you need? You need the length of all three sides of both triangles. What are you going to do? Well, we don't know whether the left goes with the left or the right goes with the right or the bottom goes with the bottom. So we're going to put small with small, medium with medium, and large with large because we know that would have to be correct. So we're going to put small over small, medium over medium, large over large, and reduce. And if they all come out equal, that means that the sides are in proportion. Therefore, we can say that they are similar by side, side, side similarity. So to be similar by side, 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 all three pairs of corresponding sides must be in proportion, meaning that the ratio of small to small, medium, medium, and large to large come out equal. So in the examples, we want to determine whether the triangles are similar, and if so, name the similarity. Okay? So here we go with example 1. We would put small with small, and medium with medium, and large with large. I've got to make this work just a second. And so we're going to put small, smallest of this one 8, with smallest of this one 4. So small 8 goes with small 4. The medium size would be 12 here, and the medium size would be 6 there. And so the 12, on top would go with the 6 on bottom. And then the largest 14 would go with the largest 7. So we would put 14 over 7. And reduce. Now 8 fourths reduces to 2 over 1. 12 sixths reduces to 2 over 1. And 17 fourths reduces to 2 over 1. They all come out equal. Therefore, the sides are in proportion. Therefore, they're similar by side, side, side. Now, A, and I've got it all color-coded, was opposite the medium size side. So we would look opposite the medium size side here to find A's partner, and A's partner is F, and so F goes first. B is opposite the smallest side here, 8. So we look opposite the smallest side here, 4, and we get E, and so B goes with E. C was opposite the larger side here, 14. So we look opposite the larger side here, 7, to find C's partner, and C's partner is D, so D is named last. Everybody said we properly named the similarity. Okay? So let's look at example 2. We're going to put small 5 with small 2, medium 6 with medium 3, large 7 with large 4, and reduce. 5 over 2 will not reduce. 6 over 3 reduces to 2 over 1. 7 over 4 will not reduce. Those are not equal. Therefore, they are not similar. So if the sides are all in proportion, we say they're similar by side, side, side. So we now have 3 ways to prove that 2 triangles are similar. If all of the angles of one equal all of the angles of another, we say they're similar by angle similarity. If an angle of one triangle is equal to an angle of another, and the sides that form those angles are in proportion, then they're similar by side angle side similarity. Or if all 3 sides of one triangle are proportional to all 3 sides of another, then we say that they are similar by side similarity. So that takes us to the daily work here on Unit 7.5. We've got lots of scenarios. We have things like vertical angles are equal and alternate interior angles, and we've got reflexive property and all kinds of things going on. So just kind of be aware of that. Do we have any equal angles? We don't have all 3 sides. We've got all 3 sides of the little one, but we're missing this side of the big one. So we can't check for side, side, side. We could check for side angle side. We only know one pair of equal angles, and that's the vertical ones. And so we're going to look at the vertical angles, and then we're going to check for side angle side. Okay, so we said we had the vertical angles are equal in the middle. So this angle at C is equal to this angle at C. That's the only pair of angles we know, so we can't prove it by angle, but we do have the sides that form those angles. The sides that form the top vertical angle are 3 and 4, and the sides that form the bottom vertical angle are 6 and 8. And if we're going to check for side angle side similarity, we want to put small over small and large over large. Larges, anyway, smalls and larges. We're going to put small of the top 3 over small of the bottom 6. Large of the top 4 over large of the bottom 8. So we have a pair of equal vertical angles, and we're taking the sides that form those angles and putting small over small with large over large and reducing, and 3/6 reduces to a half, and 1/4 reduces to a half. And so we have an angle of one triangle equal an angle of another. The sides that form those angles are proportional, therefore they are similar by side angle side similarity. Now A was opposite that smaller side 3, so we're going to look opposite that smaller side 6 and get Q. See that? So A goes to Q. You might have thought, well, A goes to P because they make a Z, but that's not the case. Small, angle opposite small goes with angle opposite small. B. B was the angle opposite the large. So we got to look at the angle opposite the large, and we get P. And then the C's were your verticals, and so C equals C. Okay? So those lines obviously are not parallel. AB and QP are obviously not parallel. They must be tilted in just a hair, just enough to make them not be parallel. You can't assume anything, you see. You have to go by patterns and rules and theorems and definitions, okay? QP. We want to find QP. Its partner is 3.5. Now, how do I know that for sure? Well, QP is the first two letters, and AB is the first two letters, and then QP would go to AB. Now, let's use dimensional analysis. I'm going to start with its partner, AB, and I'm going to multiply by the scale. What's the scale? Well, the small, small, large, large scale of a half. So I'm either going to use a half or 2 over 1, depending on if I'm scaling up or scaling down. Now, I'm trying to go from the 3.5 to its bigger triangle partner. So I'm trying to get bigger, so I scale up. So I use the 2 over 1 instead of the 1 over 2. And I get 7 for QP. Any questions on number 1? Okay. Let's see. Let's take a look at number 7. Let's just do number 4. Let's do number 4. I started to do it, and I backed out. Number 4. Number 7's in the back of the book. We'll do an even one for you. How's that? All right. Are they similar? Are they not? Well, we got that this is 50. So there's an angle equal angle. Do we know any more angles? Do you know that this angle is equal to this one because they're corresponding? You may say yes, but what do we have to know first? We have to know that the lines that form them are parallel. Since we don't know those are parallel, we can't say those are equal. And for the same reason, we can't say those are equal. So we've only got one set of angles. Well, we can go with one set of angles if we knew the sides. We could say little over little and big over big, but we only know one of the two sides that make the 50 for the little triangle, so we can't check for side, angle side. So we don't have enough to prove it by angle, angle. We don't have sides of the one angle to try to prove it by side, angle, side, and we don't have all three sides to try to prove it by side, 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 and so we can reach no conclusion about number 4. Okay? We really can't say they're not similar. We just don't have enough information to say they are, so it's going to put no conclusion. Okay. Let's, we'll just let you do the rest on your own. The odd ones are worked out, and you can see those. That got you enough, I think, to get you started. Again, we have discovery learning, which will lead us to the next lesson, lesson 7-6, and so you know that what goes in the blanks at the end of Unit 7.5 would be the rules that you see in Unit 7.6. All right.